My dear students, welcome back to our channel. Students, in this video I am explaining Bachelor of Education, first semester. Subject: Content cum Pedagogy of Physical Sciences. Important short and long questions and answers. Let's start quick revision. First important short question is: 1. Explain the concepts of science and scientific knowledge. Science is the study of the natural world around us, including everything from the tiniest particles to the largest galaxies. It helps us understand how things work through observation, experimentation, and evidence. For example, when we study how plants grow, we observe how they need sunlight, water, and air to survive. This is science in action. Scientific knowledge refers to the facts, concepts, and theories that we learn through scientific methods. It's not just about collecting information, but about understanding how and why things happen. For instance, we know that water boils at 100 degrees Celsius at sea level because scientists have tested and proven it through experiments over time. In simple words, science is about asking questions, finding answers, and understanding the world better. Scientific knowledge helps us improve our lives, like inventing medicines, building technology, and solving problems like pollution. It is based on facts that can be tested and trusted. Next important short question is: 2. What do you understand by Constructivist approach in Pedagogy of Physical Sciences? The Constructivist approach in teaching physical science is based on the idea that students learn best when they actively build their own understanding, rather than just being told facts. In this approach, students don't just memorize information but make sense of it by connecting new knowledge to what they already know. For example, instead of telling students how gravity works, a teacher might ask them to drop different objects from the same height and observe what happens. They can then discuss their observations and ideas, leading them to understand that gravity pulls things towards the earth. In constructivism, the teacher acts as a guide or facilitator, encouraging students to ask questions, explore, and think critically. This approach helps students to develop problem-solving skills, curiosity, and a deeper understanding of physical science concepts. It also makes learning more engaging and meaningful for students. Next important short question is: 3. Describe the critical and creative pedagogy in learning concepts in science. Critical pedagogy in science education encourages students to question and think deeply about scientific concepts, rather than just accepting information. It helps students understand the why behind things. For example, instead of simply learning about climate change, students might discuss its causes, effects, and how it impacts different communities, encouraging them to think critically about environmental issues and solutions. Creative pedagogy encourages students to use their imagination to explore science concepts in new and innovative ways. It allows them to come up with their own ideas, solutions, and experiments. For instance, students could create a model of the solar system using recycled materials or design an experiment to show how plants grow under different light conditions. Together, critical and creative pedagogy make science learning more interactive and fun. It helps students not only understand science, but also develop problem-solving skills, creativity, and the ability to think independently. Next important short question is: 4. What is the meaning and nature of content cum methodology in physical sciences? Content cum methodology in physical science refers to the combination of the subject matter, content, and the way it is taught, methodology. It means that the teacher needs to not only understand the science topics well but also know the best teaching methods to help students understand these concepts. For example, when teaching the concept of Newton's laws of motion, the content includes the laws themselves and how they explain the movement of objects. The methodology involves using practical demonstrations, such as showing how a car moves when pushed, to make the concept easier for students to understand. In simple words, content-cum methodology ensures that the teacher uses both solid knowledge and effective teaching methods to help students grasp science concepts. It helps make learning more interactive and meaningful, encouraging students to explore, question, and apply what they learn in real-life situations. Next important short question is: 5. What are the characteristics of secondary stage learners with reference to physical sciences? Secondary stage learners, students in middle and high school, have certain characteristics that influence how they learn physical sciences. 1. Developing critical thinking. At this stage, students start to think more critically and logically. For example, they may begin to question why certain scientific laws, like Newton's laws of motion, apply in different situations. 2. Abstract thinking. They can understand more abstract concepts. For instance, they can grasp ideas like atoms and molecules, which are not directly visible but influence everything around us. 3. Curiosity and exploration. They have a natural curiosity about the world. A student may ask questions like, "Why does the sky look blue?" and want to explore the scientific explanations behind it. 4. Hands-on learning. They often learn best through experiments and practical activities. For example, conducting experiments on how light bends in water can help them understand the concept of refraction. These characteristics guide teachers to use interactive, inquiry-based methods to make science more engaging for secondary learners. Next important short question is: 6. Write a short note on inquiry-based approach. The inquiry-based approach is a teaching method where students learn by asking questions, investigating, and discovering answers themselves, rather than just being given information. In this approach, the teacher acts as a guide, encouraging students to explore and think critically. For example, instead of just telling students about how plants make food through photosynthesis, a teacher may ask, "What do you think happens to a plant if it doesn't get sunlight?" Students would then investigate by conducting experiments or researching the process on their own, drawing conclusions through their observations. This approach helps students develop problem-solving skills, curiosity, and a deeper understanding of concepts. It also encourages them to take ownership of their learning. Inquiry-based learning is effective in physical science because it connects theoretical knowledge to real-world experiences, making learning more engaging and meaningful. Next important short question is: 7. What are the aims of teaching and learning science? The main aims of teaching and learning science are: 1. Developing scientific knowledge, to help students understand basic scientific concepts like the laws of motion or the water cycle. For example, students learn why objects fall to the ground due to gravity. 2. Encouraging critical thinking. Science encourages students to question and think logically. For instance, when studying electricity, students may ask how current flows through wires and why it's dangerous to touch exposed wires. 3. Building problem-solving skills. Science teaches students how to approach and solve problems. For example, they might solve real-world issues like how to reduce pollution or make clean energy sources. 4. Promoting curiosity and exploration. Science aims to spark curiosity about the world. Students might wonder why the sky is blue or how plants grow, leading them to explore and discover more. In short, the aim of teaching science is to help students develop knowledge, skills, and attitudes to understand and engage with the world around them. Next important short question is 8. Write about the nature of science. The nature of science refers to how science works and the way it helps us understand the world around us. Science is based on facts, observation, and experimentation. It involves making predictions, testing them, and then drawing conclusions based on evidence. Science is dynamic and always evolving. New discoveries can change what we know. For example, in the past, people believed the earth was flat, but through science, we now know it's round. Science is also systematic, meaning it follows a structured approach. Scientists use the scientific method, which includes asking questions, forming hypotheses, conducting experiments, and analyzing results. For instance, when studying how plants grow, scientists might test different amounts of water to see what helps them grow best. In simple words, science is about exploring, discovering, and continuously seeking knowledge through observation and experiments. It helps us make sense of nature and solve everyday problems. Next important short question is 9. Write a note on Socratic pedagogy. Socratic pedagogy is a teaching method based on asking questions to encourage critical thinking and discussions, rather than just giving answers. Named after the ancient Greek philosopher Socrates, this approach helps students develop their own understanding by questioning ideas, assumptions, and concepts. In a Socratic classroom, the teacher does not directly provide answers but asks thought-provoking questions to guide students toward discovering knowledge themselves. For example, if students are learning about the law of motion, the teacher might ask, "Why do you think an object keeps moving once it starts?" This leads students to think deeply and come up with their own explanations. The aim of Socratic pedagogy is to encourage students to think critically, question assumptions, and reflect on their learning. It promotes active participation and helps students develop a deeper understanding of the subject. This method is effective in physical sciences as it encourages inquiry and exploration. Next important short question is 10. List the methods of data collection in science. In science, data collection is an important step in experiments and research. Here are some common methods of data collection. 1. Observation. Scientists watch and record what happens during an experiment or in nature. For example, observing how plants grow under different light conditions. 2. Survey or questionnaire, collecting data by asking people questions. For instance, a survey might ask students about their study habits to understand how it affects their performance. 3. Experiments, conducting controlled tests where variables are changed to see the effect. For example, testing how different temperatures affect the rate at which sugar dissolves in water. 4. Interviews, speaking directly to people to gather detailed information. For example, interviewing farmers to learn about the impact of climate change on crops. 5. Secondary data, using existing data collected by other scientists or organizations, like weather records or health statistics. Each method helps scientists gather information to answer questions and test theories. Next important short question is 11. What is meant by scientific temper? Scientific temper refers to an attitude of reasoning, critical thinking, and evidence-based judgment. It means approaching problems and ideas with an open mind, curiosity, and a willingness to question assumptions. A person with scientific temper looks at facts, conducts experiments, and makes decisions based on evidence rather than superstition or unverified beliefs. For example, when learning about vaccines, a person with scientific temper will seek to understand the scientific research, the benefits of vaccines, and the evidence supporting their use, rather than relying on rumors or misconceptions. They will look for credible sources, critically evaluate information, and make informed decisions based on science. In India, promoting scientific temper is important to encourage rational thinking and help people make decisions based on facts, which is essential for progress in education, health, and technology. It encourages students to challenge outdated beliefs and understand the world through science and reason. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject quick revision. Important questions. Previous question papers. And syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.